Anatomy Assignment 3, Part 2. Following on from Part 1, we're going to start with breathing mechanisms. Breathing mechanisms is very simple. It's similar to what we spoke about at the start. It's the inhalation-exhalation process. It's where the external intercostal muscles obviously contract and pull the rib cage out, expanding the chest cavity, and the diaphragm then relaxes and moves down. Therefore, contracts, and moves down, therefore creating a larger space in the chest cavity for more oxygen to be inhaled. And then during expiration, the internal intercostal muscles will relax, the diaphragm will relax, and internal intercostal muscles will contract, and the diaphragm will relax, pushing up, therefore squeezing all the air out of the chest through the nasal cavity in the mouth. So therefore, we're able to inhale more oxygen and then eliminate of more carbon dioxide. So therefore, obviously, this helps the performer as the more oxygen we're able to take in, the more oxygen we can supply to the working muscles, and therefore the higher the intensity the performer can work at. Lung volumes. There are three types of lung volumes. We have the tidal volume, vital capacity, and residual volume. Tidal volume is the amount of air that we can inhale and exhale in one breath. So therefore, again, obviously, similar to the breathing mechanism, obviously the more oxygen we can take in, and the more carbon dioxide we can eliminate of. So therefore, the more oxygen we have, the more oxygen we supply to the muscles. Therefore, the longer and the higher the intensity can be that the performer can work at. So an example of that would be a marathon runner would require a good tidal volume, as the more air they can inhale, the more oxygen that's supplied to their working muscles, which will allow them to work at a higher intensity for a longer duration of time. Secondly, there is vital capacity. Vital capacity is the amount of air that can be breathed in, can be breathed out after inhalation. So therefore, obviously, having a good vital capacity will also, again, aid a marathon runner, as they're able to eliminate more carbon dioxide at a faster rate. Therefore, they're able to work for longer without reaching that level of fatigue, as the carbon dioxide is out of the body. Therefore, a lot more oxygen is present. So therefore, when oxygen is present, this prevents lactic acid buildup. Thirdly, we have residual volume. Residual volume is the amount of air that's left in the lungs after exhalation. So after we've breathed out, it's what's left in the chest cavity area. So for example, a marathon runner would require a strong residual volume, as they require large amounts of oxygen to be able to work at a high intensity. Therefore, the more oxygen that's left in our chest cavity after we've breathed out, the oxygen and nutrients that are left in that chest cavity can then obviously be moved on to be diffused through gaseous exchange and then supplied to our muscles. Again, so therefore, obviously, we've got, again, more oxygen, more nutrients, more proteins to be able to be supplied to our working muscles, therefore to keep them working at that higher intensity for as long as is required. Control of breathing. There are two types of breathing. We have chemical control and neural control. Chemical control is the chemical control is also to do with our breathing rate, as our breathing rate consists of like small chemoreceptors, and these detect carbon dioxide within our blood. Then chemoreceptors will obviously then tell the brain that we require a lot more oxygen in certain areas of the body. So therefore, the brain will sort out the capillary network around the lungs to expand and gain larger, which therefore will then increase the blood flow to the lungs, so more diffusion, more gaseous exchange can take place in the alveoli, therefore more oxygen can be supplied, and therefore obviously more oxygen that goes to our working muscles, again, higher intensity we're able to work at, and therefore the brain can also stop a lot of blood flow going to certain areas that aren't required, such as the stomach. In a marathon, in our stomach, all the blood going to the stomach isn't required as much, so therefore we can constrict there and prevent masses of blood going to the stomach, and therefore that will increase the blood flow going to the rest of the body. We also have neural control. Neural control consists of the brainstem, which controls the rate of breathing during exercise. Well, neural control is an unconscious act, similar to the heart, as the heart, obviously, when beats, we can't control whether our heart beats. It's involuntary, and therefore neural control is involuntary breathing in a sense, really. It reacts within less than a second. As soon as you're unconscious, it will react to that and then breathe at you. It keeps your oxygen levels high, your carbon dioxide and hydrogen ions in the blood real high at a rate that can keep you breathing and obviously keep you alive. Finally, follow an oxygen molecule. The oxygen molecule will start obviously in the air. You breathe that in through the nasal cavity and the mouth. You obviously go through then down the pharynx and past the pharynx and the larynx on the way down through the trachea. You then go into the bronchi and into the alveoli at the lungs. This is obviously where diffusion takes place. You then obviously go back to the heart, which is then pumped through around the body, all stopping off all the major muscle groups and providing oxygen and blood flow to the muscle groups. And therefore, obviously, you'll return back to the heart via all your pulmonary veins in order to go back to the heart to get sent again to the lungs to be all go back through the cycle of gaseous exchange. Thank you.